parallel plate capacitor. These are two plates which are placed parallel to one another. So in this type of capacitor, there are two conducting parallel plates, say this one and this one, of equal area, and they are insulated from each other, and they are at a distance of d from one another. Just consider a vacuum or air as the non-conducting medium between these two, and we'll try to find out the formula for the capacitance. Now suppose that electric charge on this capacitor is Q. The value of the surface density of charge on it will be sigma will be Q by A. Let us say that A is the area and Q is the charge. So sigma will be the surface density of the charge will be sigma Q by A. D is the distance between them, so D is kept very small as compared to the dimension of each plate. Because of this, the non-uniformity of the electric field near the ends of the plates we can neglect. Otherwise, if the distance is large, it will be considerable. And the entire region between the plates of the electric field E, we can take it as constant. So the uniform electric field in the region between two plates due to positive plate, we know, we have already learned this. So the electric field because of a plate or uniformly placed charged plates is nothing but sigma by 2 epsilon naught. This is in the direction from positive to negative. The uniform electric field in the same region due to negative plate. This is because of positive plate. Because of this positive plate, it will be sigma by 2 epsilon naught, this one. And because of this negative plate, it will be sigma by 2 epsilon naught because of this negative plate. And this direction will always also be in the same, means positive to negative plate. Now we got this E1 and E2. So these two fields are in the same direction. So we can just, this is direction, same direction, we can add them. So E1 plus E2 will be sigma by 2 epsilon naught and sigma by 2 epsilon naught. We can add, it will be sigma by epsilon naught. And this is in the direction from positive to negative plate. So this eventually comes to be, because sigma is Q by A, we can write sigma by Q by A here. So it will be Q by A and epsilon naught. So in the region on the other side of the plate, here or here, E1 and E2 will be in the opposite direction. So the resultant electric field will be 0 because the direction will be opposite. If the potential difference between these two plates, say from here to here, it is V. We know that V will be equal to E into D. D is the separation, E is the electric field. From this equation, we can just write V as E into D. E is, you can write like this. You can take it here. It will be Q by epsilon naught A D. And we also know that C, the capacitance is Q by V. So we get the capacitance of a parallel plate capacitor as what? Just put this V here now. So Q by V, the things which get cancelled, C will be epsilon naught A by D. So very clear from this expression that if the distance between two plates, capacitance is inversely proportional to distance. So if the distance between two plates, say, just take some measurement, 1 meter by 1 meter, the distance is 1 millimeter, the capacitance will be, we know the epsilon naught, we know the A, we know the D, just put it here, it will be 8.85 into 10 to the power minus 9 farad. So if we want 1 farad capacitance, then the area of each plate just kept at a separation of say 1 mm should be what? Area should be, we need to find out the area now. So this will be C into D by epsilon naught. Just put it here, it will be this much. So each of the length and the breadth of each plate should be nearly 10 kilometer. See, this is what we require. And this is just an idea that we'll be using this in solving the questions so that we understand what is the electric field, the potential and the capacitance between these two plates.